All right, so in front of us we have a 4-wire platinum 100 ohm RTD. 100 ohms being the resistance that it produces when it's at 0 degrees C, or the ice point. So all RTDs, there'll be a PT, which stands for platinum, PT 100, PT 200, PT 1000. That number is the ice point of the resistance value it's going to produce at its ice point. We also have a Thermowell here that we're going to be experimenting. We're going to be comparing the response time of the RTD with the Thermowell around it and without it later on in the lab. Yeah, it's a 4-wire. We're going to be using this in 2-wire configuration, 3-wire configuration throughout the lab. And like I said, there's many different types of RTDs. Sometimes they usually should have the type stamped on it, but this one doesn't. So what we're going to be doing is, at the start here, is we're going to be identifying which type of RTD we have. So what I have in front of us is an RTD table. This RTD table is used to compare the resistance in ohms, these are all resistance values, versus the temperature in degrees C. So PT stands for platinum. We have a platinum, and it's a 100 ohm platinum RTD, you can see here, and it has a coefficient. This is a temperature coefficient, how many ohms it's going to change per degree C. So there's 2 different types of platinum 100 ohm RTDs used in different parts of the world. So we do want to make sure that we identify which one it is. I'll just go to this table here. You can see it has a different temperature coefficient. Everything else is pretty much identical, but it has a different temperature coefficient up at the top here. And just to prove that these values down here are different, what I wanted to do was compare 2 values on the table. First, identify that here at 0 degrees C, we have 100 ohms. So that's our ice point. We should see the same thing on the other table here, the first one I showed you. Right there, it's at 100 as well at 0. But if we look at a value, say something higher, let's look at 100 degrees C. At 100, we're at 138.51 ohms. So let's say 38.51. 38.51, let's go over to here. At 100, we're at 39.2, so there's a slight difference. And this, if we're trying to do really precise temperature measurement, it's critical that we get the right RTD, that we're using the correct RTD. So what I wanted to do is to identify this, and to speed things up, I grabbed another RTD and threw it into our Fluke dry block calibrator here. And I've connected, I'm using all 4 wires here, 4-wire RTD being the most accurate in comparison to the 2 and the 3, because we wanted to get a precise resistance measurement. And just to show you from the Fluke manual, this is the wiring configuration I'm using on page 25. On page 25 of the Fluke 725, we're using the Fluke 725 calibrator here. That's where our leads are going to, and we're measuring the resistance. And if you look, we're at 138.52 ohms exactly. And over here we're at exactly 100 degrees C. So that tells us that we are using this one with the 0.00385, because if we scroll down on the table here, at 100 ohms, we're at 138.51, and that is the exact reading that is on our Fluke 725 calibrator. Now, just to show you that our 4-wire measurement is more accurate here, by using all 4 wires here, what I wanted to do is switch to the 2-wire configuration. So I'll go ahead and make. All right, so to switch to the 2-wire configuration, I just had to unplug 2 of the wires here from the calibrator, and now we are only using 1 red lead and 1 black lead, which would be one of from one side of the resistor and from the other side. These 2 white wires go to one side of the resistor, these 2 red wires go to the other side. So now we're just using one of these, or sorry, 1 red and 1 white or black lead here. And you can see that our resistance is higher. It's at 138.83, which is higher than 138.51 that we had before. We're still at 100 degrees C. But the reason for that is these leads here have resistance in them, and that resistance gets added to this measurement. By using the 4-wire RTD, that resistance gets canceled out and is not seen. But since we're using the 2-wire, we see that resistance, and so it throws error in our measurement. We're going to experiment more with this in the lab here, using a 4-wire RTD on a transmitter. I've wired my RTD into the transmitter here. You can see I've used all 4 wires, and we've got the Trex communicator connected up to the transmitter. It's a smart transmitter. The transmitter is a Rosemount 644. And we've got our power coming over here from our 24-volt power supply with the 250 ohm resistor here in series so that our Trex communicator can communicate to the transmitter. So what we want to do first, we're going to do some experiments here with lead wire resistance on this RTD. We need to tell the device what we have connected to it. So we're going to click here on the field communicator and it should communicate to our transmitter. We want to tell it that we're using a 4-wire RTD and it's a platinum 100 ohm RTD, and we want to tell it the coefficient that we discovered our RTD is, the 0.00385 coefficient. So this screen will load up, and the first thing we'll want to do, we're going to want to go to configure, manual setup, our sensor. We want to configure our sensor first, and I see it's already set up, but we'll go here just to point it out. We wanted a PT, which stands for platinum, 100 ohm as the ice point, so at 0 degrees C it'll read 100 ohms. And the alpha there is 385. They've shortened it basically. That's actually 0.00385 as the temperature coefficient. You can see our other options here. The 391, the 3916, or the 392 are some other options, and some different ice points as well, the platinum 200. And there's more further down. We've got the correct one selected. We also want to make sure this is set up for a 4-wire. You can see right here there's a little wiring diagram on the transmitter depending on what you're using. If it's a thermocouple, that plus minus represents the thermocouple because it sources a voltage. 2-wire RTD would be across pins 2 and 3, and a 4-wire RTD would be 1, 2, 3, and 4. And the 3-wire, you would have one of the colors, the red or the white at the 1, and then the other 2 colors on the 2 and 3. So we're all set up. We'll click OK. And also we're going to be doing this after the 2-wire offset should be set to 0. We'll be doing that after. We'll send this out to the device, so it's saying the main change is that 4-wire. We went from 3 to 4. One other thing I wanted to do too is to change our, we should be able to reset the sensor calibration. This is just in case other students be using this transmitter. If someone calibrated it incorrectly, we can put the calibration mode, put it back to factory trim. So if we click that, click OK, and it should set it back to the factory trim. You can see our lower and upper points here, minus 200, 850 degrees C. And all that degrees C is what we want, so we're good there. We'll go back to the main screen, to the overview screen, and this is where we're going to do our verification. We want to make sure that the transmitter is functional, that it's working. We're going to do a 1-point verification. I had this in an ice bath before, so it's a little cooler than room temperature right now. We're going to be taking our 4-wire RTD and putting it in an ice bath and agitating it here, and we should see the temperature drop on our screen here. We want to confirm that it comes down to pretty well 0 degrees C, or the ice point. It's dropping fairly quickly, it's getting pretty close. We'll just keep agitating this. So the benefit of using the 4-wire RTD for verifying this is the 2 and the 3-wire are a little bit more susceptible to changes in lead wire resistance. And so we're using that as our 1-point check here, and you can see that it is pretty well exactly just slightly above 0. So we're getting a pretty good reading there. That's our 1-point check, and now we know we can proceed with the rest of our experiments here in the lab. Alright, so now that we've verified our RTD as a 4-wire RTD and confirmed it's reading 0 in an ice bath, I've connected just 2 of the wires. We want to simulate a 2-wire RTD. This transmitter can take an input from a 2-wire RTD. You can see I've got a 2-wire RTD sitting right here, but we're just going to use the one that we've verified here and can set it up for a 2-wire configuration using one lead from either side of the platinum resistor at the end of the RTD there. So what we need to do in the transmitter here now is we need to configure it to be a 2-wire RTD. So to do that, you can see it's set up for a 4-wire. We're going to go in here, change that to be 2-wire. And one other thing that we need to also change for our test here, we're going to be changing the lead wire resistance to see how that affects the 2-wire RTD. We need to make sure that this 2-wire offset is set for 0 ohms. So that's there to correct for lead wire resistance, and we want it to be set for 0 ohms so we can see the full error. So we've got that set up, and now we want to make sure we send this out to the transmitter so it makes the change. And then we'll go back to the overview screen, and we should be reading the overview screen down here, and we should be reading a temperature now over here. Yeah, so we're right around room temperature, about 20 degrees, 21 degrees Celsius. So yeah, next up we're going to be adding some resistors in here to see how that affects the reading over here, our temperature reading, when we change the lead wire resistance for a 2-wire RTD. Right, so now all I've added is a 10 ohm resistor right here. You can see it's connected to the red lead and of our 2-wire RTD. And if we look over here now, we're reading way out. We're at 46 degrees C when we should be reading around 21 degrees C. All right, so I've wired up a 3-wire RTD because the next step in the lab is going to be to see how that same 10 ohm resistor, we're going to try it on each one of these 3 wires to see how it affects the reading. I've wired it in, but what I haven't done yet is I need to change the configuration here to a 3-wire RTD. It's the same type, but if you look here now, we've got the way that it's wired up is a little bit different. We need one side of the platinum resistor to be in 1, so I've got red in 1, and then the other side, the 2 white wires go to the other side. They need to be across pins 2 and 3. So now it's wired up for a 3-wire RTD, and you can see right here I've got a 3-wire RTD. It only has the 3 wires, so they do exist. I just wanted to show that, but we are just using our 4-wire RTD to kind of simulate each one of these. So I need to go back over here, push configure, and go to the connection. We want to change this connection now. We want to edit it and make it a 3-wire connection. And we are going to be working with a 4-wire connection as well, so that's where we would go to change that. So it's changed. We need to send it out to the device, and now hopefully our device should start reading correctly. So just wait for this to send, and there we go. We're back to about 21 degrees C room temperature. Right, so for doing this test, we want to make sure that the temperature here of our RTD is stable, that it's cooled down or it's warmed up to room temperature before doing these. And that just might take submerging it in some room temperature water to kind of bring it up to temperature and kind of agitating it. It shouldn't take long to bring it up to temperature. So now the next step in the lab, I'm not going to do it in the video here, but we're going to be adding a 10 ohm resistor each one of these wires to see how that affects the reading. And then we're going to do the same thing with a 4-wire. We're going to use all four of these leads and see how that affects our reading here over on the Trex communicator. All right, so one other thing I wanted to show is to show what I have here is I've got a thermocouple and a 2-wire RTD in front of us. The 2-wire RTD has the alligator clips connected to it right now. But if you look, a thermocouple will always only have 2 wires. And right there I have a type J thermocouple. It's got a red and a white lead. You can see the difference is the thermocouple will output a voltage related to the temperature, and the RTD will just change its resistance. So right now, just to kind of prove that we do have a 100 ohm platinum RTD here, I'm just going to agitate. This isn't a really great ice bath. I just got a little bit of ice and water in there, but I'm just going to agitate this, and you can see right there we're pretty close to 100 ohms. So we're pretty close to 0 degrees C with this in this cup here. We're pretty well at 100 ohms. If we were to connect those leads now across the thermocouple, we wouldn't get that same measurement. All right, so you can see now I've hooked the leads up there across the thermocouple. Another giveaway for the thermocouple is it'll usually have this brown outer jacket here, a different outer jacket where they're grouped together like that to identify it. But it could easily be mistaken that this red and, I don't have enough strip back there, but this red and white wire could be mistaken for an RTD. And so if you look over here now, we're not outputting 100 ohms, we're at 5 ohms. And also if I take it and I switch and I now measure a voltage here, you can see we've got a millivolt value showing up now. I'm not 100%, I might have the polarity backwards here, but Yeah, this should probably be a negative voltage. I'll just go ahead and switch the polarity. Positive to the white, negative to the red here. I just switched the polarity. And oh yeah, we're gonna get a negative, it's saying a negative overload, so it's because we're reading a negative voltage. But yes, if we had, we'll just switch the polarity back here. And now it's reversed, and this would actually be a negative point, a negative almost 1 millivolt, or 0.99 millivolts, there we are, 1 millivolt. So we're outputting a millivolt value. If I was to connect these leads to an RTD, we will not see any millivolt value. Thermocouple outputs a millivolt, and RTD changes its resistance with temperature. And so there now, I've got the leads connected back to the RTD, and I'm looking for a millivolt value here. I've toggled this to millivolts on our Fluke 725, and it's reading 0 millivolts, because this thing will not generate any millivolts, it only changes its resistance. If I toggle back here, press the resistance button here, it needs to be set for 2-wire, and there you can see we're back close to 100 ohms. And if I just agitate this, it should even drop down lower, closer to 100 ohms. So there, RTD measures changes its resistance. Thermocouple changes the voltage that it generates with temperature. All right, so in the last part of this lab, what we're going to be doing is we're going to be taking our RTD that we used here, just connecting up with 2 wires, 2 leads running over to our Fluke here, and we're going to have it set with this toggle. Then we need to set this to measure, so we toggle this so it's at measure like it just was, and then we also need to set the RTD to platinum 100 right there, and it needs to be set for 2-wire. If you move these up and down arrows, you can change it from 2, 3, and 4. It needs to be set for 2-wire, platinum 100, and it will read 21.33. To toggle between the RTD, we push this button until it says PT 100, PT standing for platinum. So it's at around room temperature, not bad. There's probably a slight error due to lead wire resistance, but in this last experiment, what we're wanting to do is we want to compare the response time of the RTD when it is not in the protective thermocouple and when it is. So we're going to be using our ice bath. We're going to be dropping this in, and we're going to be recording every few seconds until this drops down to 0 degrees in our ice bath. I don't have an ice bath in here right now, but that's what we'll be using, is a cup with an ice bath in it. We're going to keep recording until it drops down to 0 and is stable. And then we're going to compare, we're going to warm this back up, and then we're going to install our Thermowell on the RTD, thread this on, leave it set up in the 2-wire configuration, and then make sure that everything's at room temperature here and that we're reading stable right here. And now we're going to submerge this whole assembly, and we need to go at least to the threads here, right? So might as well go right up to the top here, submerge it in the water, and agitate it, and record the temperature on our Fluke here every few seconds until it reaches 0 degrees C. We want to compare the response time with a Thermowell versus the response time without a Thermowell. It is an advantage to have a Thermowell for easy calibration and also for protecting the RTD, but we want to see how that affects the response time.